Hi, hello, vanakkam, and welcome back to another episode on your favorite Little Slaw YouTube channel. So today in this video, we're going to see about not this part, but we're going to see about how to do thread dump analysis using Dynatrace, and that's going to be more interesting. And this module you should definitely understand if you're someone who is using Dynatrace, and this will definitely help you to understand more about the threads. I mean, we had a lot seen lots of videos on different states of threads, and we saw about various pointers on how the thread dumps work. But in this video, we will see how to analyze or how to find or how to drill down the threads, the thread dumps using um, Dynatrace. That's going to be more interesting because comparing to any other tools, Dynatrace has a lot of advantages, and you can have a better look on various interesting part. But as usual, before we move on to this video, this is me, Vasan Shanmugam. I welcome you all to our Little Slaw YouTube channel. Please don't forget to subscribe to our channel if you haven't subscribed yet. And the one that you're seeing now is our performance testing website, the littleslawacademy.github.io, where I've started adding pages, and you can go through the contents as well rather than seeing the videos. And if you want to really understand more, you can even watch the video where I have given a different perspective of what is performance testing and various other topics. And for those who could not watch the video, you can go through this, and you can gain a lot of knowledge, and you can very well prepare for interviews as well, because these are mostly prepared in terms of the interview aspect as well. So you can just go through, watch, read it, and you can have a better understanding. And with no further delay, let's go to the video. And coming back to this one, so this is our Dynatrace window, the Dynatrace dashboards. And for the last few days, we are also seeing about various Dynatrace dashboards. We saw about what are the important metrics that we want to see as a performance tester, and also we have created several performance testing related metrics in terms of CPU, the logs, and the memory, the garbage collection. But now, since this was a question that's been asked from one of our subscribers for a long time, and so today I've come up with that solution. So to go before to the thread dump, before that we have to navigate, or we have to search for profiling. So we all know what a profiling does. So we have to search for the profiling and optimization application, and that will help you to navigate to the thread dumps. So before we move on to see about the thread dumps, the CPU profiling, let's understand what exactly is profiling. So profiling is, so we know about performance testing, know about performance engineering, but what exactly is profiling? What does it do? So profiling is mainly the process of analyzing an application to understand its behavior. That's very important to understand. We have to understand the behavior of the application, right? And then the performance, and then how much resource does it consume during the execution, not during the other time, but during the execution. So three things. One is to understand the behavior, the second is to understand its performance, and the third one is to um, understand the resource consumption during its execution. So why do we need this, and who does it really help? So this profiling that we are seeing now, the window we are in now, actually helps the developers and the system admins, and even the performance testings, the performance engineers, the site reliability engineers, to gain a lot of insights into how their software utilizes the system resources such as CPU. So like you see here, we can gain insights on the CPU, we can gain insights on the memory, the input output threads, and the network as well. So profiling, we commonly used it to identify the bottlenecks, the inefficiencies, or for any issues in code. So that's what we're going to see, right? We're going to drill down until the last method in the code. So that negatively affect the performance, the scalability, and the stability. And the first part of it is the CPU profiling, so continuous CPU profiling. So what does this do? So here we're going to measure how much CPU time is spent. So here, if you can see, it's consumed CPU. So that shows us like how much CPU time is spent executing different parts of the code, and it also helps us to identify the parts of the application that consumes too much CPU, which leads to performance degradation. So we're going to see all of them, and then also we can do a CPU profiling that exactly pinpoints for any inefficient algorithms or functions that are overused. And then when it comes to the memory dumps, which normally call it as the memory usage, so So far there is no memory dumps found, but yeah, we'll just try to find out something for the memory dumps as well. And when it comes to memory dumps, so they help us to analyze how the application allocates and frees the memory, and also it helps to identify if any memory leaks. So mainly the garbage collection. So where when the memory is allocated but it's not properly released, and then it also helps us to measure the heap and the stack usage, and for tracking memory fragmentation, and for help. It actually helps us to reduce the excessive memory consumptions, which can lead to performance issues and crashes. So that's the reason we have to monitor the memory dump. So coming back to the profiling and optimization, where we are going to monitor the CPU. So out of all these processes, I'm going to choose one of it, and before that, we'll see what are the actions does it have. So we can see the process group details. That's the so we all we see here are the different process groups, and it has almost like 40 process groups. And you can see the technology which on top of it is built, for example, like node.js. Then we have .NET technology, we have Apache Tomcat, the web server technology, and then we have Go, and we have one agent SDK, which is the one agent which is part of the Dynatrace, and then we have Apache Kafka. Then we have node.js, .NET. So several technologies, or several stacks we have, and then we have the process time. So for example, let me just get the top one. So here, if you see, this particular process group has the highest, the 100% of CPU time is spent in GC. And how much CPU is consumed? So it actually it shows that it is consuming like 3 minutes 571 seconds. And let me just track it down in terms of highest CPU. So if you see this particular process, the build source main.js, is having a lesser CPU time which is spent in GC, but still the consumed CPU is 13 minutes and 9.95 seconds. So let me just choose one out of it, like from the top, like how much the maximum amount of process CPU time that is spent in GC. So let me just open it. And if you come here, like you can see the processes. The process, it's like basically split in terms of process. We have like two processes in this particular CPU. And when it comes to services, so we have like lots of services, like for example, garbage collection CPU. We have garbage collection CPU in a different process group, and then we have EKS, which is the Amazon Kubernetes services. So these are the entries that we have, are the services that we have in the CPU. And then if I click on one of these, and then if I click on, so this will actually take me to the memory allocation, but I want to look into the thread. So what I'll do is I'll go back to the thread group, and the first one, so let me click on the thread. So this will take me to the thread analysis rather than the memory analysis. So we're going to see more into the thread analysis. So now if you see here, this screen is mainly about the thread analysis of the process group, which is the library cli.javascript file. And here you can see the thread states. So we all know we have like several thread states. So let me explain it to you before we move on to the next step, like what are the thread states, and um, what does this thread states tells us. So out of all these, the very first one, that's the code execution. So when I click on the code execution, you can see on the top that's like it is actually an average of like almost like between 5 10 seconds. So what does this code execution does? So why do we need to see the code execution? So this code execution, it actually refers to the time a thread spends actively running the code. So that's why you can see it on the top. And the main reason is the thread that's running is actually it actually spends actively running code. And also it executes instructions within the application. So this is the actual processing time where the CPU is actively working on the threads task. So that's why you can see the code execution is always on top. Like for example, you can see like 0.456, and so the numbers. So mainly the numbers which tells you that um, that's the amount of time the thread spends actively running the code. And when you see high code execution time, it indicates that the thread is performing significant work or calculations. And if this time is like very high, so it could point to inefficient algorithms. So if there are any inefficient algorithms in the code, so the code execution will go very high, not high, but to very high limit. Or if there are any functions that need optimizations, and also if the code execution time is very low or low, but the application is still slow, which means there are other issues. Like for example, it can be waiting on an input output, or any other logs can be in the system, or maybe any other root causes. So these are the scenarios where you can identify the actual scenario. So for example, if you see here the average number of threads to the code execution, so you can see the numbers of it. So if it's go high, which means the thread is performing significant calculations, and if it is going very high, then there is some inefficiency, and if it is going very low or very slow, then which means like it is waiting for something, or the or there could be any logs. And then the next part is the locking. So here you don't find any locking. Sorry, this is the code execution. Sorry. So this part which you see here, the shaded one, is the code execution that's what we were talking about all this time. And on the right side, I believe this is the counter for it. So it's not on the left one. So that's the average number of threads. The one you see on the left is the average number of threads, but on the one that you see on the right side is the estimated CPU time. So it's a maximum of one, I believe. Yep. So that's what the thread execution, the code execution basically talks about. And then you have the locking one. So what is locking? So locking. So if you are able to see the thread dumps, like in terms of locking, so which means that the time a thread spends waiting for access to a resource that is currently being used by another thread. So which mainly we call it as a deadlock. So one thread is waiting for access to a resource that is currently being used by the another thread. So for example, in multi-thread, a lock is used to ensure that only one thread can access a shared resource at a time, which prevents issues like race condition or data corruption. So if you are seeing a high locking time, which indicates that the threads are often blocked and they are waiting for other threads to release the locks on shared resources, and which is typically a sign of poor concurrency management, or there could be a contention over shared resources. And some of the common issues are deadlocks, where two or more threads are stuck waiting on each other, or inefficient locking strategies. And reducing locking time can which also involves rethinking how our resources are shared between threads, and improving thread synchronization, or reducing the need for locking by using non-blocking algorithms. So these are the scenarios where you have to look about the locking. And then you have the third one, which is the disk input output. So, as we all know, it's a very common metric. So, disk input output refers to the time a thread spends reading from or writing to the disk. So that's why we call it as input output. So, reading or writing, which can be accessing files, accessing databases, or any other storage systems. So, this is the period when the thread is performing input output operations involving storage devices. So, when you see a high disk input output time, that indicates that the application is disk bound, meaning that a significant portion of time is spent waiting for data to be read from or returned to the disk. Systems that can also reduce the disk input output. And then you have the network input output. So here, in fact, you don't find any of these metrics, but still let me give you an idea. Like, so the network input output refers to the time a thread spends waiting for data to be sent or received from network. So this could involve communication with external servers, the APIs, the databases, or any other network-based resources. And then finally, you can see the estimated CPU time. So this estimated CPU time will refer to the approximate amount of time that the CPU spends executing the thread's instructions, right? So mainly it's between the CPU and the thread. So how much time the CPU spends to execute the thread. So this is the total processing time which is attributed to the thread's work on the CPU. So when you see high CPU time, which means the thread is doing a lot of processing, which is possibly indicating CPU bound operations such as heavy calculations, data processing, or tight loops. Even though there are like high CPU usage that can be normal for computationally intensive tasks, even it can also be a sign of inefficiency, like unoptimized code, unnecessary calculations, or CPU bottlenecks. And these optimizations, the way that we recommend, or the way that we optimize the code, which will reduce the CPU time, which involves optimizing the algorithms, parallelizing the tasks, or offloading work to the other resources. And now, so yeah, we saw about the thread states, and then we saw about what all these threads talks about. And then when we go to the CPU time, so here you can see the estimated CPU time which we have just seen. So what kind of uh, what exactly it shows us is that the amount of CPU that has been spent for the threads instructions or the threads execution. And then here we have got one thread group, the main thread group. And if you want to drill down, so click on the three dots and click on the method hotspots. And this will take us to the hotspots, the method hotspots which are involved for that particular main process group, the process. And if you want to see what exactly this timer process timers does, so for example, like if you want to see the call hierarchy, you can do it, or if you want to see the hotspots, also you can do it very well. But let's now do it via the call hierarchy, because by doing this, you'll be able to find who exactly is making all these problems in terms of the performance. So click on keep on clicking, and then at one point of time you will be able to see which particular task or which particular thread is taking too much of time. So here if you can see like page.js anonymous is taking like 35.4% of the total, 68% of the overall contribution. So this exactly is the culprit. So you have to take it to the development team, and then you have to make sure that that's been fixed. And if you see for the second one, it's like the async hooks emit hook, like it took like 12.1% of the total contribution, and then you have like emit hook. So for example, let's go to the very first one and we'll just drill down it better. So you can either choose calling methods, or you can either choose source code. So let me just click on calling methods, and here you can see it actually sorry, let me click here itself. Yeah, so it will take you to the calling method. So the previous one, it is actually calling the methods of the timer list on timeout. And if I click on it again, let me just click on the source code. So this will actually, okay, let me just click and try to see whether I can see it. Okay, fine. I don't think I have access to the source code, but yeah, still I was able to find, for example, click continuous CPU profiling, and let me just choose some other process group. And inside this process, so here, yeah, you can see a lot of processes that are running. And if you click on services, okay, there are no services, but still there are like a lot of the process groups. And out of which, let me select one of these and click on the threads. And this will, okay, so we don't have any threads for it. Okay, let me choose some other application with easy trade. And let me click on the three dots, go to the breakdown. So this will help me to break down the issue or break down the, so here, yeah, you can see the total, the detailed CPU consumption. And let me just take it for 1 hour. So yeah, for the last 1 hour, you can see how much is the detailed consumption and the break background thread CPU. So for example, if I just click on the three dots and click on the method hotspot, so this will take me to the what are all the responsible threads that is part of the particular process, that whatever we see high response times. So when you click on drilling down, you can very well understand. And if you come back to the CPU consumption here, and let me come back again. Yeah, so let me just check whether I haven't missed anything. So yeah, I'm in the CPU profiling, click on the three dots, click on breakdown, and let's see whether you can still for the method hotspots. And let me click on this one and then the method hotspots. Yes, there are like 103 stack trace samples analyzed, and here you can see the code execution for it. And then we could see several thread pool work queue that dispatch that's been waiting, and you can see out of 100%, 86.4% of the contribution has been taken by the thread locks. And here you can see the clouds event helper, which is like the methods that they were using it. So when I click on expand, yeah, so here you can see like there are like several stacks that's been part of this particular thread, the part of this particular process group. So that's why it is taking too much of time, and it actually slows down your application. It actually slows down your latency. So this way you can find what exactly is happening using the thread pool. So you can see here the thread pool work queue.dispatch, and there are like several stack frames. For example, the async task method builder. So let me just try to click and find. Yeah, so if I click on, so okay, I don't get access to the source code, sorry. But if in your project, I think you can just click on that particular three dots, and then you can choose whatever source code you want to see. So let me just click on calling methods. Yeah, so here you can see these are the top hotspots. These are the top hotspots, the top methods that's been calling. So lambda compiler dot delegate. We've got default binder select method, runtime dot get method, pl common. So these are the very common the hotspots that has been part of the thread group. So yeah, I believe I have explained you in terms of the CPU, in terms of the thread dumps. So tomorrow, if possible, we'll try to see the memory analysis, the memory dump analysis. So until we meet in the next video, it's bye bye from Asan Shanmugam and your favorite Little Slaw YouTube channel. Take care and bye bye.